For millennia, humanity has gazed upon the vast, mysterious cosmos, wondering about origins, secrets, and its ultimate meaning. The universe we inhabit is filled with paradoxes, endless beauty and breathtaking dangers, order and chaos, certainty and unknowns. Some see the universe as an unfeeling expanse, indifferent to the lives of those who gaze upon it. Others see it as a harmonious whole, a living, interconnected web in which every particle plays a vital role. In recent centuries, our pursuit of knowledge has taken us farther from Earth's surface than ever before. Modern astronomy and quantum physics offer insights that were inconceivable to past generations. Yet, the more we learn, the more we realize how much we do not know. We've discovered that the universe might not be singular, but may exist as part of a vast multiverse, a cosmic tapestry woven with infinite possibilities. We've learned about the existence of astronomical events so powerful they can alter life on Earth in an instant, and with each discovery, we are confronted by the fragility of our existence and the realization that, in cosmic terms, we are but a fleeting moment. In 1564, a boy was born in Pisa, Italy, grew up with an insatiable curiosity that set him apart even as a child. The eldest son of a musician was fascinated by the harmony of numbers and nature, a passion that later led him to abandon medical studies for mathematics and philosophy. His relentless quest for truth would pierce the veil of the heavens, revealing moons orbiting Jupiter, Venus shifting in phases, and a rugged, imperfect moon, shattering the notion of celestial perfection. His work affirmed the sun as the solar system's true center, challenging deeply held beliefs and enduring fierce opposition. His life was both a scientific and philosophical journey, reminding us that to understand the cosmos is to seek humanity's place within it. You are absolutely correct if you guessed his name as Galileo Galilei. This journey will take us into the depths of the universe's most intriguing mysteries, offering a glimpse into the forces that shape our reality and challenge our understanding of existence. We will explore the impact of solar maximum in 2025, a period of heightened solar activity that could significantly impact life on Earth. How do events on our sun have the power to disrupt our technology, communication, and even our daily lives? And what does this tell us about the delicate balance of life on this planet? How dangerous are entities that populate the cosmos, like asteroids, black holes, and other phenomena capable of obliterating worlds? In this vast and hostile universe, Earth appears as a fragile oasis, shielded yet exposed. Also, we will venture into the mind-bending concept that shades the light on possibility of having interstellar beings outside our blue planet, which suggests that our life may be but one of countless others. If true, this idea upends everything we think we know about reality, individuality, and existence itself. What might these other lives be like? And could they hold other versions of ourselves? Are we living out just one thread in an infinite web of possibilities? Or does our planet have a unique role in this cosmic drama? As we delve into these profound questions, we invite you to reflect on your place in this boundless cosmos. How do you reconcile the enormity of the universe with the fleeting nature of human life? Are we passive spectators of these cosmic forces? Or do we have a role to play in shaping our understanding of them? Through the exploration of these mysteries, we hope to inspire a deeper connection to the universe and a sense of wonder that transcends the ordinary. You're watching Space Nine, unveiling the mysteries of the cosmos, your gateway to the universe. Earth's solar trial in 2025. The solar maximum, peak of the sun's 11-year natural cycle, is a period of heightened solar activity marked by an increase in sunspots, solar flares, and coronal mass ejections. The next solar maximum, expected around 2025, is predicted to be particularly intense, with significant implications for Earth and modern technology. While solar activity is a natural part of our sun's life cycle, its effects on our increasingly interconnected and technology-reliant world make it a subject of growing concern and study. This cycle is driven by the sun's magnetic field, which flips polarity at the end of each cycle. During a solar maximum, the sun's surface becomes more turbulent, with an increased appearance of dark, cooler regions known as sunspots. These sunspots are often accompanied by massive eruptions of charged particles from the sun's corona. During this phase, sun produces solar flares, which are intense bursts of energy resulting from the sudden release of magnetic energy in sunspots. Solar flares emit X-rays and ultraviolet radiation, which can impact the upper atmosphere and interfere with communication signals on Earth. Coronal mass ejections, which are the large clouds of charged particles ejected from the sun's surface at incredible speeds, sometimes exceeding 1,000,000 miles per hour. When directed toward Earth, they can cause geomagnetic storms, which disrupt the planet's magnetic field. The number of sunspots observed correlates with the intensity of the solar maximum. More sunspots typically mean greater solar activity, making the cycle more impactful on Earth. The effects of heightened solar activity during a solar maximum extend far beyond the sun itself, influencing Earth's magnetosphere, a protective shield formed by Earth's magnetic field that deflects charged solar particles. When coronal mass ejections collide with this magnetic shield, the resulting geomagnetic storms can have wide-ranging consequences. Disruptions to satellites and GPS that can damage satellites, disrupt their communication signals, and interfere with the GPS systems that underpin modern navigation, logistics, and even everyday apps. Impact on telecommunications and air travel, especially high-frequency signals, can be disrupted during solar storms. Airlines that rely on such communications, particularly in polar routes, may face challenges, including rerouted flights to avoid regions with higher solar radiation. Power grid vulnerability that can induce currents in power grids, potentially causing voltage instability or even widespread power outages. Historical examples, such as the 1989 geomagnetic storm that knocked out power in Quebec, Canada, highlight the risks posed by a strong solar maximum. Auroras and atmospheric effects that can produce stunning visual phenomena, such as the aurora borealis and aurora australis. These occur when charged particles collide with Earth's atmosphere, creating beautiful displays of light. As we approach the 2025 solar maximum, scientists, governments, and private industries are focusing on minimizing risks and enhancing resilience to solar activity. Forecasting of solar storms has improved our ability to predict solar storms. Satellites such as the Solar and Heliospheric Observatory, SOHO, and Parker Solar Probe provide valuable data about solar activity in real time. Companies are developing hardened satellites with better shielding to withstand solar radiation and implementing protocols to temporarily shut down or reorient satellites during intense solar events. Utilities are investing in infrastructure upgrades and grid hardening to prevent disruptions caused by geomagnetic storms. Emergency protocols are in place to handle potential blackouts. Efforts going in spreading awareness and international cooperation between nations to share data and coordinate responses. Educational campaigns aim to raise awareness of solar storm impacts among industries and the public. Also, airlines are improving contingency plans to reroute flights, while GPS-dependent industries are incorporating backup systems to reduce reliance on potentially disrupted signals. As we brace for the solar maximum in 2025, we're reminded of the profound connection between our planet and its star. How might future solar cycles challenge our rapidly evolving technological landscape? Are we prepared to protect critical systems against the full force of the sun's power? And beyond the risks, could understanding solar cycles help us unlock deeper insights into the sun's mysteries and its influence on life on Earth? This solar maximum presents not only a challenge, but also an opportunity to deepen our relationship with the sun, a celestial entity that is both our lifeblood and, at times, a formidable force of nature. Dangerous objects in the universe. The universe is filled with magnificent yet dangerous phenomena that can destroy planets, stars, and even galaxies. Let's explore some of these cosmic hazards and their potential impact on Earth. Relativistic jets are among the most powerful and potentially hazardous phenomena in the universe. These high-energy beams of plasma and electromagnetic radiation, ejected from regions near black holes or neutron stars, travel at velocities close to the speed of light. While they play a role in shaping galaxies and the intergalactic medium, their immense energy and unpredictable trajectories make them some of the most dangerous forces in the cosmos. If one were to intersect our solar system, the consequences could be catastrophic, underscoring their destructive potential on both local and cosmic scales. Relativistic jets originate in the extreme environments around compact objects like supermassive black holes, neutron stars, or stellar mass black holes in binary systems. When matter is drawn toward a black hole, it forms an accretion disk, a spinning disk of superheated material. This process generates powerful magnetic fields capable of funneling plasma outward at nearly light speed. The energy required for this process is immense, often sourced from the rotational energy of the black hole itself via the Blanford-Znajek process, or the angular momentum of the accretion disk, the Blanford-Payne mechanism. The result is a beam of particles traveling across interstellar or intergalactic space with staggering force. Relativistic jets can stretch for thousands to millions of light years, effectively punching through the fabric of galaxies and interacting with everything in their path. So what makes relativistic jets dangerous? Relativistic jets pose significant risks due to their speed, energy, and radiation output. Unlike other cosmic phenomena that rely on proximity to be dangerous, relativistic jets can cause destruction across vast distances. Here's how. Relativistic jets emit intense gamma rays, X-rays, and other high-energy radiation. If a jet were to point directly at Earth, this radiation could strip away the ozone layer, exposing the surface to lethal ultraviolet rays from the sun. A prolonged gamma ray burst from a relativistic jet could lead to mass extinction, disrupting ecosystems and atmospheric chemistry. Atmospheric erosion. The intense electromagnetic energy of a jet could ionize Earth's atmosphere, depleting its protective layers and destabilizing the climate. The impact would be similar to that theorized for gamma-ray bursts, which have been implicated in past mass extinction events on Earth. Shockwaves and plasma interaction. A relativistic jet's beam could physically interact with the solar system, generating shockwaves through the interstellar medium. These waves could disrupt planetary magnetospheres, destroy satellite infrastructure, and wreak havoc on electrical systems. Gravitational disruption near the source of a relativistic jet, such as a black hole, could destabilize the orbits of nearby celestial bodies. While this is unlikely on Earth's scale, a sufficiently close encounter could send asteroids or comets careening toward us. Some of the examples of relativistic jets are blazar jets. Blazars are active galactic nuclei with relativistic jets aligned almost directly toward Earth. Their intense brightness is a warning of their potential power. If such a jet's energy extended far enough, it could devastate planets in its path. Gamma-ray bursts. These short-lived but extraordinarily powerful bursts are believed to result from relativistic jets formed during stellar collapses or neutron star mergers. A gamma-ray burst aligned with Earth could result in mass extinction. The Ordovician-Silurian extinction, which occurred 450 million years ago, has been hypothesized to have been caused by such an event. Messier 87, Jet, the supermassive black hole in the galaxy. M87 produces a jet over 5,000 light-years long. Though not aimed at Earth, Its immense energy serves as a sobering reminder of the destructive potential of these cosmic engines. Now, one of the common questions that comes to mind is, could a relativistic jet endanger Earth? While relativistic jets are typically located far from Earth, the risk remains non-zero. Jets originating from gamma-ray bursts or blazars could reach Earth if their source is sufficiently close. Even a distant jet could have profound effects on the interstellar medium, potentially impacting the solar system indirectly. Relativistic jets are not only dangerous locally, but also influence galactic and intergalactic ecosystems. They can strip galaxies of their star-forming gas, halting the creation of new stars. Jets also heat and displace intergalactic gas, which affects the growth of cosmic structures. While these processes are fascinating from a scientific perspective, they remind us of the violent forces constantly shaping the universe. Relativistic jets exemplify the dual nature of the universe, simultaneously awe-inspiring and terrifying. They are colossal beacons of energy that illuminate the workings of black holes and galactic evolution, but they also highlight the fragility of life in a cosmos filled with uncontrollable forces. As we study these jets, we must grapple with the question, how many of these high-energy behemoths are active, and how many may one day pose a direct threat to our tiny corner of the universe? Hypervelocity stars, cosmic runaways and potential harbingers of destruction. Hypervelocity stars are some of the most intriguing yet potentially hazardous objects in the cosmos. These stars travel through space at staggering speeds, millions of kilometers per hour, fast enough to escape their host galaxies entirely. These stellar runaways challenge our understanding of galactic dynamics, but they also pose significant threats to their surroundings. Their immense speeds, gravitational influence, and potential to disrupt celestial systems make them a hidden danger in the universe. Hypervelocity stars are typically ejected from galaxies through violent gravitational interactions. One common mechanism involves binary star systems venturing too close to a supermassive black hole. The black hole's immense tidal forces tear the binary apart, capturing one star and slinging the other outward at extreme speeds. This process, known as the Rahil's mechanism, turns the ejected star into a cosmic projectile, hurtling through space at velocities exceeding 1,000 kilometers per second. Other hypervelocity stars may be the remnants of catastrophic events, such as a supernova explosion in a binary system. When one star in the binary detonates, the companion can be launched at tremendous speeds, carrying with it the energy of the explosion. These mechanisms underscore the chaotic and often violent nature of the universe, where stars themselves can become cosmic weapons. Hypervelocity stars are not inherently destructive in their composition, but are perilous due to their immense kinetic energy and gravitational influence. Traveling at such extreme speeds, they can traverse vast distances, potentially crossing through star systems or even galaxies. The dangers they pose include gravitational disruption. As a hypervelocity star passes near a planetary system, its gravitational pull can perturb the orbits of planets, asteroids, and comets. Such disruptions could destabilize entire solar systems, leading to collisions between celestial bodies or planets being flung into interstellar space, triggering cosmic chain reactions, as this star passing through an asteroid belt or a region dense with comets could scatter these objects, increasing the likelihood of impacts on nearby planets. On Earth, such an event could mirror the asteroid impact that caused the extinction of the dinosaurs, but on a potentially larger scale. Radiation and stellar winds, as many hypervelocity stars are massive and young, emitting intense radiation and powerful stellar winds. These emissions could erode the atmospheres of planets they encounter, stripping away protective layers like ozone and leaving the surface exposed to deadly cosmic radiation. Direct collision scenarios. Though its exceedingly rare occurrence, the the possibility exists that a hypervelocity star could collide with another star or planet. The energy released in such an impact would be catastrophic, potentially outshining entire galaxies in a brief but violent explosion. Astronomers have identified several hypervelocity stars within and beyond the Milky Way. For instance, the hypervelocity star HE 0437, 5439, discovered in the Large Magellanic Cloud, is travelling at an astonishing 2.6 million kilometers per hour. Though not on a collision course with Earth, its sheer speed and energy illustrate the potential hazards such stars could pose if one were to approach our solar system. Another example is the hypervelocity star S5 HVS1, located just 29,000 light-years from Earth. Travelling at 1,700 kilometers per second, it was likely ejected by the supermassive black hole at the centre of the Milky Way. These discoveries highlight the presence of hypervelocity stars in our cosmic neighbourhood and the importance of tracking their trajectories. Hypervelocity stars do more than pose localised dangers. They influence the dynamics of galaxies and interstellar space. As they move through the intergalactic medium, they spread heavy elements and disturb the delicate balance of dark matter and gravitational forces. Their interactions can alter the structure of star clusters, disrupt star formation regions, and create shockwaves in the interstellar medium. So, could hypervelocity stars threaten Earth? While the probability of a hypervelocity star passing through our solar system is low, the consequences would be devastating. Even a distant encounter could perturb the orbits of planets, send asteroids hurtling toward Earth, or destabilize the Kuiper Belt and Oort cloud, regions filled with icy bodies. Such disruptions would increase the likelihood of impacts that could lead to mass extinction events. The study of hypervelocity stars is crucial not only for understanding galactic dynamics, but also for assessing potential cosmic threats. As telescopes like the European Space Agency's Gaia map the positions and motions of stars with unprecedented accuracy, astronomers are better equipped to identify hypervelocity stars and predict their trajectories. Hypervelocity stars are a stark reminder of the universe's chaotic and unpredictable nature. These stellar runaways, born from violence and travelling with unimaginable energy, highlight the delicate balance of cosmic systems. As we study them, we're reminded of our vulnerability in a universe filled with forces far beyond our control, and the need to remain ever vigilant against the potential threats they represent. Asteroids and comets are some of the most fascinating, yet potentially perilous objects in our solar system. Asteroids are rocky remnants left over from the early formation of the solar system about 4.6 billion years ago. They predominantly reside in the asteroid belt between Mars and Jupiter, though some, known as near-Earth objects, NEOs, have orbits that bring them close to our planet. These celestial bodies vary widely in size, from tiny pebbles to massive bodies spanning hundreds of kilometers, such as Ceres, the largest asteroid. Comets, on the other hand, are icy bodies originating from the distant Oort cloud or Kuiper belt. When they approach the Sun, their ice vaporizes, creating stunning tails of gas and dust that make them among the most beautiful sights in the night sky. But despite their beauty, both asteroids and comets pose significant threats to Earth. The thing that haunted the scientist community on NEOs are not the ones that are known to us, rather the unknown ones as the number in the tens of thousands, with smaller ones remaining undetected. Even a small, unexpected impact could cause regional devastation or trigger global consequences if it hits critical areas. This means it is very much possible that one day we just wake up to the news stating an NEO is coming to hit us, as their high-speed impacts could cause widespread destruction, potentially altering the climate or triggering mass extinctions, as theorized with the Chicxulub impactor that led to the dinosaurs' extinction. The study and monitoring of these cosmic neighbors have become critical for planetary defense. Space agencies like NASA and ESA are actively tracking thousands of NEOs to assess their potential risk of collision with Earth. programs such as NASA's Planetary Defense Coordination Office and missions like DART, Double Asteroid Redirection Test, aim to develop strategies for deflecting hazardous asteroids. While the likelihood of a catastrophic impact in the near future is low, even small asteroids can cause significant localized damage, as evidenced by the Chelyabinsk meteor explosion over Russia in 2013. On the other hand, these celestial bodies are not merely threats, they hold immense scientific value. Asteroids and comets act as time capsules, preserving the building blocks of our solar system, and studying them provides insights into the origins of planets and the potential for life. The dual nature of asteroids and comets, as both hazards and keys to cosmic history, makes them essential targets for ongoing exploration and research. For example, Bennu, with a diameter of about 500 meters, is a potentially hazardous asteroid with a small probability of impacting Earth in the late 22nd century. Bennu's mass and velocity mean it could unleash energy equivalent to several billion tons of TNT upon impact. NASA's OSIRIS-REx mission recently returned samples from Bennu, providing valuable data for planetary defense strategies. 1,950 DA, estimated to be over 1 kilometer in diameter, this asteroid has a potential, albeit very low chance of colliding with Earth in the year 2880. Such a large impactor would cause global-scale destruction, underscoring the importance of long-term tracking of NEOs. Apophis is the most commonly known nowadays, was discovered in 2004. This asteroid, roughly 340 meters in diameter, caused significant concern when initial calculations suggested a small chance of collision with Earth in 2029. Although further observations ruled out this scenario, its close approach, just 31,000 kilometers from Earth, makes it a key focus for ongoing observation. Interstellar beings and the potential dangers they pose. The concept of interstellar beings, entities that originate beyond our solar system, has long fascinated humanity. While largely confined to the realms of science fiction, the idea of advanced life forms capable of traversing the vastness of interstellar space also stirs scientific curiosity and existential unease. As we strive to understand our place in the cosmos, the potential risks associated with encounters with interstellar beings remain a subject of speculation, rooted in both scientific inquiry and philosophical reflection. In this discussion, we explore the nature of hypothetical interstellar beings, their potential motivations and capabilities, and the risks they might pose to humanity. By examining both scientific perspectives and imaginative possibilities, we can better understand the profound implications of such encounters, whether they lead to enlightenment or existential peril. So what are interstellar beings? Interstellar beings are hypothetical forms of life that originate from outside our solar system, potentially in other star systems, on exoplanets, or even in interstellar voids. Such beings might range from simple microbial organisms to hyper-advanced intelligent civilizations capable of traversing the vast distances between stars. The existence of interstellar beings is plausible given the vastness of the universe. With over 100 billion galaxies, each containing billions of stars and planets, the potential for life beyond Earth seems statistically likely. Efforts like the search for extraterrestrial intelligence, SETI, and the discovery of exoplanets in habitable zones reinforce the possibility of interstellar civilizations. The nature of these beings could be as varied as the environments they inhabit. They might be carbon-based life forms like us, silicon-based organisms adapted to extreme conditions, or entirely non-biological entities, such as self-replicating machines or artificial intelligences. So are there potential dangers from interstellar beings? While interstellar beings could represent opportunities for knowledge and cooperation, they might also pose risks to humanity. These dangers fall into several categories, ranging from accidental harm to deliberate hostility, such as biological threats, as interstellar beings could introduce unknown pathogens or biological agents that might devastate Earth's ecosystems. Just as diseases carried by European colonists had catastrophic effects on indigenous populations in the Americas, contact with alien microbes or viruses could overwhelm our immune systems or disrupt global ecosystems. Additionally, these beings might exploit Earth's resources, potentially introducing invasive species that outcompete native life forms. A hypothetical scenario could involve alien organisms adapted to consume Earth's organic material, leaving behind ecological devastation. Technological supremacy and hostility. If interstellar beings are advanced enough to travel across light years, their technological capabilities would far surpass our own. Such superiority could make humanity vulnerable to deliberate exploitation or extermination. Potential risks include planetary conquest, as other beings might seek to colonize Earth for its resources, leaving humanity either enslaved or eradicated. Advanced civilizations might possess weapons far beyond our comprehension, such as planet-destroying devices or energy-based systems capable of mass destruction. Even well-meaning interstellar beings could inadvertently harm us by introducing technology we cannot safely integrate, destabilizing societies and economies. Cultural and psychological risks, as contact with interstellar beings might not involve overt aggression, but could still have profound psychological and cultural impacts. The sudden realization that we are not alone in the universe could destabilize religious, philosophical, and social structures. Additionally, the sheer disparity in knowledge and understanding could render communication impossible, leading to misunderstandings or fear-driven hostility. The psychological impact of realizing our cosmic insignificance, sometimes referred to as the cosmic loneliness paradox, could also lead to widespread existential crises. Accidental harm, as these other beings might pose dangers unintentionally, much as humans have accidentally harmed ecosystems on Earth. For example, resource extraction or other industrial activities by interstellar beings could disrupt Earth's geology or atmosphere. Their mere presence could introduce unknown chemicals or radiation that harm Earth's environment. A massive interstellar spacecraft entering the solar system could destabilize planetary orbits, leading to long-term chaos. A grim possibility is that interstellar beings might be inherently predatory, viewing other civilizations as threats or resources. This concept, often explored in science fiction, is also reflected in the dark forest hypothesis by physicist and author Liu Cixin. This theory posits that intelligent civilizations may remain silent to avoid detection by potentially hostile species. In this scenario, interstellar beings might eliminate other life forms as a precautionary measure, viewing humanity as a potential future threat. Humanity's current level of preparedness for contact with interstellar beings is minimal. While organizations like SETI actively search for extraterrestrial signals, there is no global consensus on how to respond to confirmed contact. The lack of a unified strategy leaves humanity vulnerable to panic, miscommunication, or poorly planned actions. The dangers posed by interstellar beings are often explored in scientific literature and theoretical research. Examples include Kardashev-scale civilizations. Advanced civilizations might range from planetary-level societies, Type 1, to galaxy-spanning empires, Type 3. The more advanced the civilization, the greater the disparity and potential threat it poses to humanity. Von Neumann probes. Self-replicating machines sent by interstellar beings could potentially strip entire star systems of resources, posing a major threat to Earth if one arrived in our vicinity. Zoo hypothesis. Interstellar beings might already be aware of humanity and deliberately avoid contact, akin to preserving a nature reserve. However, this protective stance could change if we are perceived as a threat. Human history offers cautionary tales of first contact between civilizations of unequal power, from the colonization of the Americas to the exploitation of indigenous peoples. These events demonstrate the dangers of imbalance in knowledge, technology, and intent. If interstellar beings were to contact us, humanity's survival might hinge on how we navigate these disparities. So, are we alone? A philosophical perspective. The question of whether interstellar beings exist and what they might mean for us forces humanity to confront profound philosophical questions. Are we ready to share the cosmos with others? How would such knowledge change our understanding of life and existence? Is it better to remain hidden, as the dark forest hypothesis suggests, or to actively seek out others? The vastness of the universe and the mystery of interstellar beings remind us of our fragility and insignificance. Yet, they also inspire wonder, urging us to prepare for both the dangers and opportunities that may arise from contact. Interstellar beings represent the ultimate unknown, symbols of both cosmic curiosity and existential dread. Whether their arrival heralds an era of enlightenment or danger, humanity must approach the possibility with a balance of open-mindedness and vigilance. The potential for learning from advanced civilizations is immense, but so are the risks of miscommunication, hostility, or exploitation. In the face of such uncertainty, humanity must strive to understand the cosmos, while preparing for the profound challenges interstellar beings could bring. The key to our survival and our flourishing may lie in our ability to adapt, collaborate, and remain resilient in the face of the vast, mysterious universe that surrounds us. Conclusion: navigating the dangers of the universe. As humanity ventures further into understanding the cosmos, we are faced with a reality that is both awe-inspiring and perilous. The universe is not merely a vast expanse of stars and galaxies, but a dynamic arena filled with forces and phenomena that can pose significant risks to life on Earth. By exploring the dangers of the solar maximum, celestial objects like near-Earth objects, NEOs, relativistic jets, hypervelocity stars, and the hypothetical existence of interstellar beings, we confront our vulnerabilities and our potential for resilience. The solar maximum, a natural phase in the Sun's 11-year cycle, serves as a reminder of our dependency on a star that is both a nurturer of life and a source of existential risk. From geomagnetic storms disrupting power grids and satellites to potential interruptions in global communication and navigation systems, this event underscores the need for improved space weather forecasting and infrastructure resilience. The solar maximum is not an anomaly, but a recurring trial, urging humanity to prepare for a future where such cosmic events may grow even more consequential. Beyond solar phenomena, celestial objects introduce another layer of danger. Near-Earth objects, NEOs, asteroids and comets that approach Earth's orbit, pose a tangible threat of impact, as evidenced by historical collisions that have shaped Earth's geological and biological history. Efforts to monitor and potentially deflect these objects are advancing, but the unpredictability of smaller, undetected bodies remains a pressing concern. Meanwhile, relativistic jets, powerful streams of energy and particles emitted from black holes, illustrate the universe's raw, destructive power. While they are relatively rare and distant, the immense energy of these jets could incinerate entire star systems in their path, posing catastrophic risks to any life forms within range. Similarly, hypervelocity stars, cosmic runaways traveling at breakneck speeds, remind us of the universe's chaotic nature. While unlikely to collide with Earth directly, their movements disrupt the gravitational balance of star systems, leaving destruction in their wake. The speculative existence of interstellar beings introduces perhaps the most profound and uncertain dangers. Whether microbial life forms, advanced extraterrestrial civilizations, or self-replicating machines, interstellar entities could inadvertently or deliberately pose risks to humanity. Biological contamination, technological superiority, or miscommunication could lead to outcomes ranging from ecological devastation to existential threats. The very prospect of encountering interstellar beings forces humanity to grapple with profound questions about our readiness, our place in the cosmos, and the ethics of interstellar contact. These dangers, while daunting, also highlight humanity's capacity for innovation and survival. From improving our understanding of the sun and cosmic phenomena, to developing planetary defense systems and engaging in thoughtful speculation about extraterrestrial life, we are beginning to address the challenges of living in a dynamic and often hostile universe. However, these efforts demand global cooperation, foresight, and an acknowledgement of our collective fragility. Ultimately, exploring the dangers of the universe compels us to balance awe with preparation, curiosity with caution. The cosmos is both a cradle of inspiration and a crucible of existential risk, and humanity's future depends on its ability to navigate this duality. In embracing the challenges of the universe, we may yet secure not only our survival, but a deeper understanding of our place in the vast, enigmatic tapestry of existence. Let us know which of the facts terrified or excites you the most. Hope you enjoyed this video. Thanks for watching.